Hello again. Happy Thursday, I'm going to say. Oh, because so I can see you. But I don't know what day you're watching this. So I hope that first section went okay. We're going to move on today and look at some other principles and properties of circles. And you'll notice on the screen here, I've written the word tangent, but with an S on the end of it. So we've learned about tangent, right? It's opposite over adjacent. It's a ratio of two sides of a triangle. This is not that kind of tangent. They're sort of related in ways that aren't really pertinent to our course here, but we're going to talk about a tangent line, which has a much different definition and actually is a massive, massive topic in calculus. Now, we're not in calculus, but this is again starting to sort of lay some of the foundation for work that some of you will do down the road when you get to calculus. So let's go to work. What I'd like you to do is, as before, one other thing, it would be good if you had the notes that I sent you, like my actually teaching notes in front of you. You can follow along. We're going to go literally through that, but you can look at some of the drawings that I've put in there. And then also, I'll show you this. I have up on this other screen, this is that the packet of notes and theorems that I gave to you. So we're going to be right here to start today. So that might mean a couple of different packets and sheets of paper in front of you, in addition to your book, because we're going to do some stuff out of the book, and we're just going to be, plus notes you're taking, so I'm sure it's quite a scene where you are. So what I want you to do is I want you to draw a circle, and we're going to do something a little bit different though. So let me, first of all, draw a circle as best I can. And we'll go ahead and put a center here. But now we're going to do something a little bit different. And that thing that we're going to do different is we're going to draw a line that touches the circle in only one point. What do you think what that would look like? You can probably imagine what a line would look like if it touched the circle twice. It just goes right through the middle or on the inside. What would it look like to touch only once? It would look something like this. And I won't delay the excitement. That's what a tangent line looks like. So a tangent line, and I would include segment in that as well. Sorry. Touches a circle exactly once. And in fact, there's a name for this point right here. It's called the point of tangency. So we'll use that word, actually the phrase, the point of tangency here pretty quickly. So all we're going to look at today is two properties, two characteristics of tangent lines. But what becomes really interesting is what kind of problems those properties lead to. So I'm going to switch here real quick back to this screen, and you will now see the first theorem of this new unit. So we have this comment here that a line tangent to a circle. I want to clarify the wording on that just a little bit. We're going to treat this as an if-then statement, because you're going to see there's a converse up here. I'm going to go over right here. There's a converse coming as well. So let's think of it in terms of if a line is tangent to a circle, then that line is perpendicular to the radius at the point of tangency. So we have the point of tangency here, point of tangency here, and what we have is a perpendicular relationship between the radius and the tangent line. And by the way, there's triangles again, sorry. But there's a converse that goes with that as well. So here's what the converse is going to look like. And you can write this down as I say it, or you can just sort of think it through. But if we find a line that's perpendicular to the radius at the point of tangency, that then means that it's a tangent. So it kind of goes both ways. If we have a tangent, it's perpendicular to the radius. If a line we know is perpendicular to the radius, then the line is a tangent line. And I'll show you some examples here in just a second where we can test to see if a line that appears to be tangent truly is tangent. Okay, so we're actually adding two theorems here. We have the basic theorem and then its converse. Okay, so what I want to do is get into your books real quick. I'm going to pull my book out right here. And again, if you need a second to grab your book or track it down, you can pause this recording and get there. You know, you can never really pause me in class, right? I just get going and there's no stopping me. But now you can pause me and come back to me when you're good and ready for me. We're going to be on page 428. This is page 428. And we're going to look at example 2, A and B. So I'll give you a second to get there while I'm going to draw this circle here. So here's my circle, and I'm just going to include on my circle the points and the lines and the measurements that are shown in this drawing. So if you give me just a second, we've got a line coming out here from K. We've got a line, we have a radius that, radius that seems to come right there. And I'm trying to make it look as perpendicular as possible. I understand it's a little bit tricky to do, but and we have, oh, see how that goes? So that's going to be tangent there. I'm going to have to move this guy like that. Okay, so I want you to look at the numbers that are listed here. In fact, let me add some of the pieces. There's a K here, there's a P here, and there's a J here. And then we have some measurements of 6, 9, and 10. So the question, this is part A now. The question on part A is KJ tangent to the circle? So is this line right here, is that really a tangent? And so what the question is really asking is this, and I'm going to erase this in just a second, but is this a right angle? Okay, so let me take that off just real quick. But that's what we're trying to find out is that a right angle? And here's where I'd ask you in class, but I'm going to pause for a second to ask you this. How do we know if that's a right angle? I hope you said, if that's a right angle, then that makes a right triangle, and the Pythagorean theorem would have to hold. So let's try it out. Does 9 squared plus 6 squared equals 10 squared? It's a big question mark. 9 squared is 81. 6 squared is 36. Does that equal 100? I think you probably see where we're going. I get 117 does not equal 100. So the answer to A is no. You can see right there in your book, I'm not trying to be fancy like I made this whole thing up, but I want you to notice that indeed this doesn't satisfy the conditions of the Pythagorean theorem, and so no, it is not a right triangle. Let's go on and look at part B, same page here. We might even just take a look at the triad just a second. Let's look at part B. Now in part B, we have a circle with a known tangent. So we do have a tangent. So let me draw that out here for us. And we'll draw a radius, and we'll draw a tangent line, and we'll draw another line that goes out this way. RST. But notice that we're told that it's a tangent, and so you'll even see drawn in here, there is a right angle automatically drawn there. That's the sign that ST is in fact tangent to the circle at point S. So here's what we have. We have X here, X there. That should make sense because the radius is always going to be the same. This is 18, and this is 24. So what do we do? Well, we're trying to solve for the radius, which is x. So that's a little bit of a tricky problem. Notice that the hypotenuse can't be 18 because it has to be the longest side of the triangle. So it's got to be longer than 24 for sure. Also, the hypotenuse it's got x in it too. So we know that x is at least 6, but what are we going to do here? What we're going to do is Pythagorean theorem. X squared plus 24 squared equals, hang in there, x plus 18 squared. It's funny, Algebra 1 is just learning how to do these squaring binomials, but you guys are so far past algebra, right? All right, x squared. What is 24 squared? Well, you can look in the problem right there. It's 576. That equals, all right, let's do a quick review here of FOIL. For FOIL, we do first, we get x squared. We do outers, we get plus 18x, but then we do inners, we get another plus 18x. So this is plus 36x. And then 18 plus 18 is 324. So look at that problem, but don't freak out, because look what's going to happen. X squared here, x squared there, gone. Well, that's nice. And see, I have just an x here, but here's a number that's not x. I'm going to subtract 324 from both sides, and I get 252 equals 36x. Now we know what this game looks like, right? Divide 36, divide 36, and x equals, look in the book, x equals 7. So to be clear, this number is 7, this number is 7, but the whole hypotenuse here is 25. Because 18 plus 7 makes 25. And curiously enough, this makes a Pythagorean triple. 7, 24, 25. That's fun. So it works. Okay, I think we should try something new here. Let's try something else. Let's look at the try it on the next page. So I'm not going to probably spend a lot of time on this. Let's look at try it. Page 429. And maybe we'll just do part A. I'll leave part B for you. But so we're asking, is MP tangent to circle N? By the way, circles are usually named for their center. That's why it's called circle. See a little notation there? It's kind of a cool little symbol for a circle. So the question is MP tangent? And the way you answer that question is to see if angle NMP, or that angle at the point of tangency, see if that's a right angle, 90 degrees. How do you do that? Well, you add up 58 plus 33 and see if that equals 90. So if the other two angles add up to 90, then certainly angle M has to equal 90 as well. And you'll see that 91 is not equal to 90. So no, not a tangent. Okay. So that's fun. Let's look at that. Look at the next one. Okay. The next one, and I'm going to go back over to the theorem sheet that I have. The next theorem says that if two segments are tangent to a circle, then they're congruent. Notice there's no converse here. We're going to talk about that in just a second. So we have these two segments. Oh, hang on. Two segments tangent to a circle. So you can see segment 1, segment 2. Whoops. If they're both tangent to a circle, then we have congruence. You see these marks that are labeled here as congruent. Notice that there's no converse here, because I could never say if two segments are congruent, then they're absolutely guaranteed to be tangent to a circle. We know that's not true. Take a look at two sides of a square, for example, or a rhombus. Those are congruent sides. They're not going to be tangent to a circle necessarily. So we have two segments tangent to a circle, then they're congruent. So what that does, it actually leads to a kind of a cool I don't have it on here, shoot. It leads to kind of a cool picture. And I'm going to show you this real quick. And you can look at this. This is in your notes. I want you to see this. What you're going to find, I'm not trying to be weird here, but we're going to have some congruent triangles here. So we have right triangles. You know that the hypotenuse here of both triangles is the same side. So that's going to be congruent. You have a leg that's congruent. You also have radii that are congruent. So SSS, but we have HL from hypotenuse, a leg. These are congruent triangles. So yeah, we're back to congruent triangles again, which is kind of cool, congruent right triangles. And that now leads us to some kind of fun problems. So I want to pull up these problems now, have you take a look at these. These are in the notes I gave you. So I'm going to have you look at this for a second, then I'll put these on the board here. And we've got, I don't know, 3 or 4 problems we'll go through here. So take a look at this problem first. AC, where's AC? Good heavens. Is that the weird? Oh, that's the one down there. Ha! Let's just go up and look at this one right here. Look at this first problem right here. So let me just pretend there's a little line that boundary. What do we do with this problem? Well, here's what we know. If you'd be asked, like, what is the perimeter of this circle? We know that this side is congruent to that side. This side's congruent to that side. These are both congruent. Oops. I mean, everything is congruent all the way around here. I wonder, do we know? Let me double check this. Do we know what WU is going to be? I'm not sure that we do. I might have to skip this one. I'm not sure if we have enough information. What do you think? 22. We're not going to spend a lot of time on that one. Let's hold off on that. If you guys want to figure that out, that's really cool. Let's go and look at this next one. I'll have to get back to that one. That's kind of weird. I don't know that problem got weird. All right, so we have a new one now. AC is tangent to circle O at point C. What's the measure of angle OAC? OAC is right here. This should be very, very quick and easy for you. Because if we're tangent, then this is a right angle. That's 45. That's going to be 45. You know, that works? Really not that exciting. All right, this is one that's a little bit better that I want to do to take a look at. I want to show you why this is what it is. So get to that problem in the notes, and I'm going to switch back to the whiteboard and see if we can figure this one out. So I'm going to draw a circle like this, and then we're going to have all these tangents. This is where it gets a little bit weird. So I've got a point out here. I'm going to draw a tangent there, and a tangent here. And then we've got another tangent. Oh dear, this is going to be tricky. Let me go here and take this like that. And then we'll go here. You can see these are a little bit tricky to draw. And then we'll draw a line here. And then we'll extend this one like that. Okay, good enough. Oh, I know that drives some of you nuts. All right, I'll fix it. I promise I'll fix it. I'll fix it. Okay. Yes, I know the lines don't quite meet. I'm over it. Okay, so this whole thing here is 12. This one right here is 4 from there to there. This is 9. And this is 4 from here to here. So the question says, what's the perimeter? So this is where it gets really kind of interesting and, dare I say, fun. So we got to figure things out here. We have a couple of full sides, and then we have a couple of, like, you know, tangent lines. But what I know is if that's 4, that's 4. That's what this new theorem tells us, that two lines that are tangent to a circle are congruent. Similarly, if this is 4, That's 4 also. But then things get kind of interesting, because if that's 4, this has to be 5, right, to make 9? Which means if that's 5, this is 5. Those have to be congruent. I'll put 2 marks here. They've got to be congruent. And then if this is 4 up here, this has to be 8 to make 12. But this is congruent to this, so this has to be 8. So what I end up with for the perimeter is 12 plus 12 plus 9 plus 9. And we get 24 and 18 equals 42. We also get, if I'm not mistaken, a kite. What do you think about kites here? We have 9 and 9 here, and 12 and 12 there. I think we have a kite. Yeah. So let me go on. One more problem here, and I'm going to jump ahead to the next page so you can see this. This is a little bit different type of setup, but I think it's worth spending a little time talking about. So I'm going to put my center here. I'll let you read the problem. This is the it's the last problem. Let me go back. Too many pages open. This is the problem I'm talking about. We're going to ask you to find the measure of this angle that's out here. Right, whoops, here. That angle right there. So I'm going to go back and go on the whiteboard and figure this out. So you should have that in your notes. I will let you find that at your leisure. I'm going to draw some lines here now. I'm going to have one that goes out, let's see, goes out that way, one that comes up this way. And then we're going to have a tangent. So I'm going to have one that comes out this way, and then one that goes out that way. I'll try to clean that up just a touch, like that. Okay. And let me label these with a little bit of O here, B here, A there, C there. And this is a 92-degree angle. And I'm going to show you this word here because it's a word that's familiar to you, but probably not quite in this context. The word is circumscribed. Oh, are you kidding me? Circumscribed? That thing again? Circumscribed, remember, means drawn around the outside. So when we circumscribed a triangle about a circle, the triangle was drawn on the outside. This just means that these lines are tangents. That's a fancy way of saying the lines are tangents. So if I go back to the whiteboard, what I can tell you, well, for starters at least, is that these are going to be congruent. And curiously enough, those are also congruent. But that's not really what's important right now. If you look at the problem in the packet you have, you'll see the question's asking for the measure of angle A. What? Oh, wait a minute. If these are truly tangents, then that's a right angle, as is this. And so, yeah, we do have kind of a weird looking kite here, but one thing we know is that the sum of angles in a quadrilateral, I will draw this ever so briefly, and then I'm going to erase it. Remember that I can take any quadrilateral and take it and put it into two triangles. So the sum of angles in a quadrilateral is 300, whoops, 360 degrees. So if I call this X, I've got 90 at C plus 92 at O plus 90 at B plus X equals 360. And you can do the math if you want. This will be 272 plus X equals 360. Subtract 272. And X is going to equal 88 degrees. Or what you could have done, and some of you probably did this already, is you realize, wait a minute, if this is a 90 and that's a 90, that makes 180. So the other two have to also make 180. That's what's left. If that's 92, that's a little bit over the 90 that would cut it in half. So this one's going to be a little bit under at 88 degrees. So let me just shoot back real quick at our actually three theorems that we had and make sure that you have a grasp on them, and then that'll be that. The first theorem of the day was this one. Oh, good heavens. A line tangent to a circle. So tangents are perpendicular. Sorry, we clearly have some lag time here. Tangent lines are perpendicular to circles at the point of tangency and specifically perpendicular to the radius. And then if a line is perpendicular to the radius of a circle, then it's a tangent. So you get two theorems for the price of one there with the converse. And then we also have this fact that two tangent segments are always congruent. So that's a story for today. These problems are, let me tell you, I know we've been down this road before. These problems are a little bit confusing looking at first, but they're not bad. They're kind of fun. So give yourself a chance to explore a little bit, figure it out, and see what you can do. You've got a couple of days and a couple of different assignments to work on. As always, ask me questions, send me a text, give me a call, send me an email. If you're not sure about something, I got all the work right here. I'll help you through all of it. But have fun with that. And I will probably plan to see you again on Tuesday, March 31st. Bye.